All right, here we go, guys, on 2.5, which is perimeter and area of similar figures. You talked about what similar figures are in section 2.5, and now we are going to use that to talk about perimeter and area. So you see here this key idea. When two figures are similar, the ratio, remember ratio is just another word for fraction, the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So let's talk about, first let's talk about different ways to write ratios. So I said a ratio, you can also think of it as a fraction, but there are other ways. You can write 3:5. You could write 3 with the word 2, 5, and then you can write 3/5. And this, a fraction, is the most common way that we normally represent ratios. So that's what we're going to be doing today, is using that. So basically it says find, on example 1, find the ratio left to right perimeters of the similar rectangles. So labels, always labels. I should do something like the perimeter of the left over the perimeter of the right equals the perimeter of the left, and then we can just use one of the side lengths. So we know that this side length over here is 4, and that same side over here is 6. And of course, reduce anytime you can. So the ratio of the perimeters of these similar rectangles is 2:3. And that's it. Okay, but labels, set up your labels. I promise it'll help you. Let's move on. So this one doesn't have a picture, but it says the height of figure A is 9 feet. The height of a similar figure B is 15. So remember, similar means same shape but different size. So B is 15. What is the ratio of the perimeter of A to the perimeter of B? Perimeter of A to the perimeter of B. And we can always use one of the sides to figure this out. So one of the sides of figure A is 9. One of the sides of figure B is 15. And again, always reduce. So we can divide both of these by 3. And we get 3/5. Alrighty, and just realize that we needed another example here. So hit pause on your video and write all of this down, and then come back and we'll work it together. All right, so this one's a little bit different. It gave us the ratio and it wants us to find one of the sides. So what we've done before is we've taken lengths of the sides and use those to find the ratio. So we're going to do the same thing here. We're going to set up a proportion, because that's what we've been doing up here, is equivalent fractions. So instead of us finding the ratio, they gave it to us. So the ratio is 5:3. Now what I need, I'm going to put a label of big here and small here. How do I know that? Since they gave me the 5 first and it's bigger than 3, I know that the 5 has to go with the larger triangle. I'm sorry, the larger rectangle. So I know that that has to go there. And then so over here, I'm also going to need to do the bigger rectangle and the smaller. So put yourself some kind of label so you get everything in the right place. So they told us the ratio is 5:3 for the perimeter. So what side do we know of the big rectangle? We know 15. We do not know x. And so then we've done this a couple times this year, I think just last section. So cross multiply. 5 times x is 5x. 3 times 15 is 45. So x would equal 9. Had I put some labels on here, like let's go back and do that. Let's make this feet. So this is 9 feet. So if that were somewhere in there, you put it feet, centimeters, inches. If it's not, then no big deal. So I have a feeling you're going to have some practice on a problem like this. Otherwise, I wouldn't have added it in. All right, let's go ahead and flip the page. So flipping this page, we have another key idea. So we've been talking about perimeter and how you can make a ratio out of the perimeters. You can do the same thing with area. So now remember, area is a two-dimensional thing. So say you were finding the area of a rectangle, you do length times width. So when you are doing your labels, you would do inches times inches. So that's where we're going to wind up with a squared on these. So area is two-dimensional. We're going to be squaring things. Otherwise, we're going to use basically the same process. So here for example 2, and again, you got to pay attention to whether it's area. So, and we're going top to bottom. So we're going to do area of the top over area of the bottom. Just make yourself a little label so you know what you're doing. So, and to find the ratio of the areas, you again can use side length. So the side length they have given us for the top one is 6. The side length that they have given us for the bottom one, which is that corresponding side, is 10. And so the only thing different on here, and you know what, let's go ahead and reduce this before we even bother to put the squared on there. So let's reduce that to 3 over 5, and then you have to put squared on there. We could say that you're going to multiply that out, but I think we just leave it just like this with the squared. So the ratio of the areas would be 3 over 5 squared. And let's try one real life situation. We're going to use both of these and kind of bring it together. So if you're still kind of like, that's okay. We'll get you going right here. So a swimming pool is similar in shape to a volleyball court. Here's a pool, here's a volleyball court. Hey, they're both rectangles in this case. Find the perimeter P and the area A of the pool. Okay, and so when it says find the perimeter and the area, but we are just going to change that to find the ratios of the perimeter P and the area. So let's start with perimeter. So to find the ratio, we want to find, we can use the perimeter, let's do the pool, and then the volleyball court. So we need to find one side that they have given us and make sure it's a corresponding side of the pool. And there I see an 18 yards. So good, it's in the same label. And then on the volleyball court, I see 10. Again, always reduce. We can divide both of these by 2. And we get 9 over 5. That's improper, but that's okay. So that's the ratio of the perimeters. The ratio of the areas, so we're going to do areas here. Ratio of the area of the pool to the area of the volleyball court. Using those same numbers again, I'm going to go ahead and just use my already reduced version. So does that make sense? We got the same answer, even though one we're talking about perimeter and one we're talking about area? No, it does not. So remember that always on area, you are going to have to square that. So area, think of a rectangle like here, is going to be length times width. So our ratio of the areas is also going to be squared. If we multiplied that out, 9 times 9 on the top would be 81. 5 times 5 on the bottom would be 25. Okay, but we don't have to do that. We can just stick with that. So that's it for this section.